drop the base. You will need a calculator for today, so if you don't have one, go ahead and grab one of those. Would you hand me one? So sometimes it's not possible to get a common base. You know, if I said 2 to the x equals 3 to the x minus 1, you cannot get a common base between 2 and 3. So we need another strategy. What we have been doing with the common base, once we had it, we could drop those bases. We are going to use a new property now that if we have an exponential equation, which is where we're starting today, it's legal to add a log to each side of the equation. So instead of taking something away, we're adding something. We're going to do a log. You could do a log to any base that you wanted. Typically, we will either do a natural log or this log base 10 because those are the two buttons we have on our calculator. And we're trying to get them to the point where we can plug it into the calculator. So if I gave you this problem, 8 to the x power equals 21. Okay, the common base is still the best option we have. So you want to ask yourself every time if you can get a common base, it will be a lot shorter to do it that way. Is it possible to write both of these to the same power? No, 8 is 2 to the third, but 21 is not 2 to a power. So I can't do that. So instead, what we're going to do is add a log. So all right, so I'm just putting a log in front of each of these. Now, how does this help me? They have the same base. Think about properties of logs. What happens with this exponent? Exponents come down in front. So now I have x times log of 8 equals log of 21. So if you're trying to get x by itself, it's multiplied with something. So we divide. So we have log 21 divided by log 8. Those logs don't drop. We can put it in our calculator right now if we want a decimal. Make sure every time you push the log button, it opens a parenthesis, so make sure you close it. So if we have log 21 divided by log 8, okay, let's check it. If you go back to the very original, we had 8 to the x power equals 21. So if I do 8 to the 1.4641 power, does it equal 21 exactly? No, because we rounded, but we get 20.9997, so it's very close to 21. Did everybody get it? Yes, gotta have that. All right, let's try another one. Do you guys think you could start this one on your own?
No.
Think you can? What would we do first? Hold on. Then what happens? Properties of logs, exponents come to the front. Okay. We have x. It's multiplied with the log 3 and the 2. So I'm going to multiply by 2, or divide, excuse me, by 2 log 3. Both of them. When you plug this in, you need to be very careful. So on the top we have log of 1.4. Make sure you close that parenthesis. Around the bottom, since I want to divide by all of this, I'm going to put a parenthesis here. to log 3.
Can you just do like 2x equals whatever that equals and divide by 2?
Yep, that works as well.
Got 0.1531.
Log. So 0.1531, did everybody get that?
Yep. Would it be 0.2 since there's a 5 between?
Yes.
No?
If there was a 5, there's not. The-
Well, not,
Yeah.
no, I'm saying,
That last, the fourth one, it would be a 2. Maybe.
no,
Because there's a 3 in front
there's
of
a
the
3
1.
in front of that 5.
Alright, so why do I have a 5 right here?
Yeah, he does have a different answer.
Oh.
He has
Let me see.
his 0.15315. That's a six.
What the heck?
See, that's your main problem.
You did. Because you rounded
Ah, got it,
this
got it.
and then divided by 2.
Heard you.
Okay. Other questions?
Wait, how you check it again?
Just real quick, you don't
You-
seem okay.
I'm not
Today.
okay. I appreciate your
Is it-
concern.
You just put 3 to the.
Yeah, if you want to check it, you do 3
Might
to
need
the
to go to
2
hospital.
times.
Yeah, see,
That's
I did
not
that the
that
last
bad.
problem, I got like a giant fraction.
Oh, really?
Yeah, it's like,
Let's see if it works this time.
I don't think it worked last time.
I got 1.39989.
Yeah, I'm talking about the last problem, try that one. Just put, here, I'll put 8,
3.1415926.
1.4, correct?
Somebody changed the settings on your calculator to go into.
Great.
Shut up. It's not fun.
9230781640620.
All right, other questions?
Shut up.
Why are you doing it at such a meander pace?
Okay, let's try this one. So I put on here, we need to be careful. Before we add the logs, we always want to isolate the exponential term. Okay, we want just one exponent on that side before we add the log. Because otherwise, if you have the log of things being multiplied, you have to break it apart into multiple logs and it becomes a much more complex problem. So before I add my log, think about properties of exponents. If these two things are multiplied, what can you do with their exponents? Add them. So this becomes e to the 4x plus 1 equals 4.
Excuse you?
All right, now we have two options here. We need to add a log to each side, and you could do whatever the regular log like we have been doing. But if there's an e, I prefer the natural log. It doesn't make a difference. You'll get the same answer, but this is a little bit nicer.
But it doesn't make a difference. I have to be a little bit nicer if it doesn't make a difference.
It doesn't make a difference in the answer itself. You get the same answer when you work it out. But natural log is log base e. If you have log base e of e, what happens to that? Yeah, that whole log just goes away. So you get 4x plus 1 equals the natural log of 4. So then to get x by itself, subtract our 1. So we have the natural log of 4 with a minus 1 on the end, and then we divide by 4. Okay, so if you're going to type this in, you need to put it in like that if we're using parentheses. Do you guys know how to type things in where you can see the fraction? That might help some of you as well.
What?
To be honest with you, no.
Okay. If you hit the alpha button, that green button, and then the y equals, it has some different options.
I didn't get that option.
And that first one sets it up as a fraction, so then you can make sure that you've got.
Second, alpha.
So you'd hit the
Alpha.
alpha, so the green button, and then the y equals,
Numerator,
and
denominator.
just the first option. So then we had the
Law of natural. Yeah, for real.
I don't know.
For Ritzley.
You said that
Alpha.
natural log of e is a base of e, so it cancels out.
and since it's multiplied.
Oh, so it's, okay.
So we had what? The natural log of 4 minus 1 all divided by 4.
Yes.
It's for the game day first, though.
So we get
I can just hear him
.096 6 if we go to 4 decimal places. Did you guys get that?
Yes.
Yeah.
Okay.
I think I
It kind of depends on what else is with the problem. Like, is it multiplied by a negative or something like that? But yeah.
I think you're interested in random Jimmy.
Yeah. And that is true on this one. All right. Let's try another one together. So what would I need to do first here? And then? We add our log. What kind of log would be nicest here?
They only have
And that's just because of the e. So the 5x comes down. When you have a natural log of e, yep, that turns into 1. So to get x by itself, we have to divide by 5. So we have the natural log of 7/3 all divided by 5.
We'll let you put a fraction inside a fraction.
Should.
Should.
0.1695.
No. That's where-
And if you plug these in, you can check it.
Is it just x equals 1.1 or
Mhm.
0.16?
Yeah. Okay, I want you guys to try the next one. See how far you get with it.
Not equal.
Would a natural log be beneficial on this one? No, regular log again. Okay, but first get that exponential by itself. Tells you that you have to do exponents before you can multiply, so we can't multiply the 5 and 3 together, so instead we divide by the 5. So 3 to the x equals 6/5. So then we can add a log to each side. Properties of logs, the x comes down. So you have the log of 6/5 divided by the log of 3. And if we do that, we get
Or 0.1660.
huh? No, you don't have to.
Who's there, that shit?
All right. Let's look at this one. A little bit longer.
I think we got it.
What would we do? Add the 5.
Did divide by 4.
So we get 2 to the x plus 3 equals 20. Okay, now what? Add a log on each side. Okay, be very careful. That exponent comes down. People make mistakes because they write it like this. What's wrong with how I just wrote that?
Parentheses.
I need to put parentheses around this whole thing. So then, What should I do with my log 2?
Divide it over.
And then to get x by itself,
Yeah, I'm subtract 3.
subtract. So we have,
Is it cool we just do it last?
that'll work.
I feel like we can wait for it in the first.
We are going to do probably 2 more and then I'm going to stop for today, if that's alright. Okay.
Why don't you just sit down?
Have a seat, ma'am.
I'll go in a minute.
Wait, what was the answer to that one?
We got to ask you.
1.3219. Like that?
It's 2-0.
219.
Wait, what was the answer?
You can now.
1.3219.
Nothing?
Alright.
Hey, Fred, shut up.
Just tell me the truth.
Shut up.
Hey.
Let's look at this problem.
Come on, please.
Shut up.
It's going to add a little more to it, so I want everybody paying attention here. These problems are different. How?
There's 2 X's.
There's 2 x's. We have 2 exponentials, right? Check, is it possible to get a common base? No. If we could, that would definitely be an easier option. Since we can't, we are going to have to go with logs. So, showing all of your work is going to be really important on this one because it will have a few more steps involved. When we add our log to each side, we have log of 5 to the 2x plus log of 8 to the x plus 1.
You just subtract the x one over.
Okay, so first the exponent comes down. You're a step ahead of me, I think. So we have 2x log of 5 equals, put the x plus 1 in parentheses, log of 8. All right, now, we have to somehow get these x's on the same side. So first, let's distribute the log, and then we can subtract one.
That's not what I did.
Oh.
Since the log is multiplied with both of these. When you multiply, these are going out in front. The log 8 won't change. So it's going to become x log 8 plus 1 times log 8 is just log 8.
Yikes.
Wait a minute. Hold
I
on.
did that completely wrong.
Pause.
Like, if you go ahead. I murdered that. Jesus. It's like.
Alright. Is everybody caught up to me?
Yeah.
Okay, from here, both of these terms have an x. So I need to get those terms on the same side. So I'm going to subtract over the x log 8. They aren't actually like terms, so I can't combine them. But I have them on the same side.
If we divide by the log of 8,
They
we
cancel.
cancel the 1.
We can't divide yet. Both of these terms have what? So we can take out that x. So that gives us 2 log 5 minus log 8 equals log 8. So now you have x times something, so now is when you divide. So we have log 8 divided by 2 log 5 minus log 8. So this is the exact answer. You're going to have Math Excel tonight, and a lot of them are A and B. Part A is the exact answer, typing this, and Part B is the decimal approximation. This one, if it helps you, you can do that fraction trick
Wait.
that I showed you. So if we hit the alpha y equals, we can put in a fraction. So then we have the log 8, close the parentheses around the 8. Then the bottom 2 log 5, close that parenthesis, minus log 8. So my decimal approximation is 1.82. Right. The 9 would round up, so we'll just 1.825 or 8250. All right. We'll try one more like that and then we're done. So you guys tell me, what is my first step?
We need to put the logs on the same side.
Well, first we have to do what with our x?
Drop them. Then like just like.
Would it be x log plus, log 4?
X times log 4.
I didn't know if you would break it down further.
No, so this side it's just x times that. Now over here, because our exponent was 2 terms, we have to distribute that log to both of them. So 1 times log 3 is log 3 minus 2x log 3.
Yeah, wouldn't that be 6x?
When you're multiplying, it gets multiplied in front of the log. So log 3 is just like a number, and anything else just goes in front. It won't change the argument. So, both of these terms have an x. We need them on the same side. So we add over the 2x log 3. What would you do now?
Comment. GCF.
DCF, we take out that x. And we have log 4 plus 2 log 3. So if I ask for the exact answer, that's the log 3 divided by log 4 plus 2 log 3. If I ask for the decimal, we put it in the calculator. I think on most of the homework questions, it asks you to round to the nearest thousandth, which is 3 decimal places. My general rule, we do 3 to 4, so we've done 4 on a lot of these, but just round according to the directions on your problems.
What about that x? For the bottom,
Uh-huh.
what happens to that x?
We factored it out right here, and then I just divided by everything except the x, so it left the x by itself. You guys get 0.3066?
No.
No, at .2641, or 42.
Did I mistype
I
something?
got what you got.
I
I got what you got.
If you didn't get it,